Hi you guys, so we're going to be learning about box and whisker plots today. We are going to first go over some definitions though. You guys already have your mean, median, and mode, but we're just going to rewrite these just so we can have them all in one place of our set of notes. So in order to find the mean, you are taking the average of the values, which means that you are taking the sum of all those data values and dividing it by the number of data points that there are in that set. Okay, then the next thing is the median. This is the middle value. Basically, you put it in order from least to greatest and then figure out what the middle value is. Okay, and then the mode is the most occurring values. Okay, and then now this is the part where we're going to be learning for our box and whisker plot. The reason why we did the mean, median, and mode was because we actually are going to be using the mean a lot, and we want to, and actually means a Q2 as well. So this is the median is our Q2. So that's another name for that we'll be using. Okay, so for our lower extreme, this is going to be the smallest value of our data set. And then the upper is going to be the largest value. And then the lower quartile is going to be the median. And of course I will explain all of this to you guys in an example on our next slide in 1 second once we make sure we get all of these definitions down. So lower quartile is the median, the middle of the first half, and then the upper quartile is the median of the upper half, or the second half. Okay, and then just I want to also put in parentheses here, you guys, that there are different names. So just like this Q2 is called the median, the lower extreme is called the min, the upper extreme is called the max, the lower quartile is going to be our Q1. That's why our Q2 is the median. And then our Q3 is the upper quartile. So those are just different names for those. Our range is, we actually had defined that as well in our previous notes. We have our max minus the min. And again, that's our highest value minus the lowest value. And then it's going to be something similar to interquartile range. We're going to take the quartiles and we're actually going to subtract the Q3, the upper quartile, minus the lower quartile, which is called the Q1. So this is basically the range between the quartiles. Alright you guys, so that's the definitions. Let's go over an example. So for our example here, we're going to be given the data. This is actually our data set 4, 10, 10, 14, 4, 25, 15, 22, 16, and 10. We're going to find each of these data values here. So our mean, we're going to add up all of these data values. So I'm going to be adding up 4 plus 10 plus 10 plus 14 plus 4 plus 25 plus 15 plus 22 plus 16 plus 10, and I got 130. I'm going to divide by the number of values that are actually in my data set. So about 3, 4, 5, 6, 7, 8, 9, 10. So divide this by 10, and that ends up getting me 13. What's nice about the mean is you don't have to have it from least to greatest. So now let's just keep going across. Let's say what our lower extreme is. So our lowest value that we have is 4. So this is going to be, remember, our Q1. And then we have our lower quartile. We'll have to figure that out in a second. Maybe actually let's go down. Let's do our upper extreme. Our highest number we have is 25, and that's going to be, our lower extreme. This is going to be, let's rewrite that. So our lower extreme is actually our min. This will be our max. And then let's figure out our median. So our median, a lot of you guys just want to make sure we are doing this correctly. We have to put this data set from least to greatest. Okay, so I'm going to go, we have 4. I cross them out as I go so that I make sure that I got them all. And then we have 10, 10. The next number is 14. 14. And then 15. 16, Then we have 22 and 25. Oh, and I missed a 10. Let's squeeze a little 10 in here. So I have 1, 2, 3 10s now. Now I got rid of that one, and then we have a 25. So double check how many numbers again. Remember we divided by 10, so I should have 10 numbers here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect, and this should not be 114, it should just be 14. Okay, so now I have my numbers from least to greatest. Perfect. So now I can start going through and crossing off to find my middle value. And once I get to my middle value, then that's going to be my median. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So I actually have to go back. I can't cross that one out. So I have two numbers here. Remember, you have to take the average, the mean, when you actually get two values. So I'm going to do 10 plus 14, which equals 24. I'm going to divide that by 2 because there was two numbers I'm taking the average of, and that gets me 12. So my median is now 12. Okay, and then the most number that occurred was 10 because this is I saw that it happened 3 times. And then now I'm going to make sure, let's actually label these. So this is my median is also my Q2. We have my min, my max, and then now we're going to actually figure out, since we have the divide here in our median number here, we now have to find in order to get our lower quartile, we need to figure out the median of this lower half. Since we had two numbers in our median already, we actually have to include that one when we're crossing out to find the median. Now, all of a sudden I have 10 as my lower quartile. This is also called your Q1. So 10 is my lower quartile. Then in order to find my Q3, I now need to find the median of this value. Again, since I have two numbers in the middle, I'm going to include those when I'm crossing off. And then my number is 16. That is now my quartile 3. If you guys were only to have one number in the middle here, you would not include it when you're crossing off and finding your quartile 1 and your quartile 3. Okay, let's do our last minute thing. So our range is going to be our highest value, our upper extreme, our max minus our min. So 25 minus 4, we get 21. And then our interquartile range, we are taking our upper quartile right here, our Q3 minus our Q1. So now we have 16 minus 10, and we get 6. All right. So now we are going to use this data, you guys, to actually create a box and whisker plot. So these are, actually, sorry, let me pause. I'm just going to clear up some of our data here, so make sure you guys have all this written down so that we can actually create a box and whisker plot and see what it looks like. So now that I have some space here, we're going to use all the numbers that we were given. So it's called the 5-number summary. The 5 things I'm looking for is my min, my Q1, my median, my Q2, and my max. So those are the only numbers I actually care about when I'm creating a box and whisker plot. I'm going to go ahead and create a number line, and I'm going to count by 2s. Okay, so I went and counted by 2s. When you're making a number line, you have to be consistent. So I went from my min to my max. So now I'm going to start putting values at where I actually see these here. So my min was 4, put a line right there. Then my quartile 1 was 10, so I'm going to put a line at 10. And then I'm going to go to my median, which was 12. And then my quartile 2, which is median and is quartile 2. So this should actually be your quartile 3 is part of your summary. Sorry about that. So now I'm going to go to my quartile 3, which is your upper quartile, and this is 16. This is your Q3. And then my max, which is going to be 25. So it's right in the middle there. So in order to create your box, it's those 3 lines in the middle there, and then your whiskers are the outside. And that's your box and whisker. Now we're just going to go over a couple pieces of data in order just to compare what our box and whisker plots look like. So go ahead and take some time to draw these out so you guys can have the actual example written down. So what is the median of each set? Median, remember, is your Q2. That was that value that was right there in the middle. So on both of them, on A, it's 70. On B, it is also 70. Okay. Awesome. So now which plot has lesser range? So if we look at A, we have our range, which is our max minus our min. So 100 minus 50 is 50. For part B, 100 minus 40 is actually 60. So which has the lesser range? Well, A only had a range of 50, so it would be A. All right, then we look at our next one. Which plot has the greater interquartile range? So now we're looking at our max quartile Q3 minus our Q1, which is 80 minus 65, which is 15. And then we have our next one, which is 85 minus 60, so 25. So B has the greater quartile range of 25. Now we're going to figure out which upper quartile, what is the actual upper quartile of each. So my upper quartile, we actually just figured that out. A was the 80, and B was 85. So we're just kind of doing a reverse. We created box plot first, and then now we're actually having box plots and going backwards. Which of these, which is the lower extreme of each set? So a lower extreme is our quartile 1. So again here, we just figured that out. It was 65 for A. And then for B, it was 60. Now what percent of the data is in, I'm sorry, I just gave you, so not the quartile, the lower extreme would be the min, you guys, so sorry about that. Your A value, your lower, so the lower extreme, which is your min. So for A, that was actually here, so that would be 50, and for B, it would be 40. Okay, so now what percent of the data in plot B is between 60 and 85? So let me erase this so we can see what we're talking about again. So right now I want to figure out on part B between 60 and 85. So what's nice about this is that this was the middle of our value. So that means that we have 50% of our data on this side and 50% of our data on that side. Well, these happen to be the middles of each of those data sets. So what's different about this, it doesn't look like it, but these are actually each 25% little sections of our data. So what lies between 60 and our 85 right there? It is 50%. Okay, and now what percent of the data in plot A is greater than 85? So again, if we go to our 85 right here, sorry, 80, if we go to 80, we want to see what's greater. Well, look, if we look down here, it's still 25% of our data. So 25% is over 80 in our plot A. Now, what percent of the data in plot B is less than 85? So again, if we take a look, let me change the color so we can see it. So I have 85 here. We're trying to figure out what data is less. So I'm just going to add up 25, 25, 25. We get 75%. All right, you guys go ahead and look back, slow down, go through these examples for our box and whisker plots, and I'll see you in class. Thanks.